be doing your Boyle's Law Lab. Okay, and so you should have a copy of your lab that looks like this. Okay, you won't need your safety glasses for this lab. You'll just need 10 textbooks, big textbooks, not small ones. You'll get a kit with a syringe, 2 wooden blocks, and in your drawer number 4, you guys should have your rec lamps, and the ring stand should be at your desk. Now, when you set this up, be sure that you guys have the block that has the rubber stopper on the bottom. Okay, this rubber stopper here is tapered. And that's to fit the end of the syringe in. Do not use the block that does not have the rubber stopper in there. If you use this block, it will not block the air, and as soon as you start stacking your books on the syringe will go all the way down to 0. So again, this one needs to be on the bottom at the tip of the syringe. The one without the rubber stopper is going to be the one that goes on the top. Okay, so that's the first thing I want to go ahead and talk to you guys about. So we'll tighten this down. And the second thing is, before you guys get started, make sure that these are as level as possible, so when you look at your syringe this way and you look at your syringe this way, it's as 90 degrees as possible. The reason is you're going to be stacking 10 books up on top of this, and if this is at an angle, okay, if it is at an angle, make sure the angle tilts inward, but if it is at an angle, it's more likely to fall over. But if you have a choice and for some reason it has to be at an angle, adjust it to where the longer one is on the bottom and the shorter one's on the top, so that way it leans in towards this pole, and that'll make it easier for you to balance. So again, those are warnings in order to prevent you from having to redo the lab later on. Okay, so at this point I've got my lab apparatus set up. Depending on your class, you guys will have to weigh your books or find out what the force of gravity is of them in newtons, and that's what this is for. So we're going to go ahead and we'll take our scale, or not our scale, but our newton meter, and you'll take your textbook, and then you're going to set your textbook inside here. And in this case here, this textbook is 22, 24, maybe 20, we'll just say 24 newtons. And so what I'll need you to do is write on the board the force of gravity pulling down on your textbook. Okay. All right. Now, before we get started with placing our books on the piston, what we want to make sure we do is we measure the radius of our syringe. Okay. Now, measuring the radius is going to be a pain because there is no direct center on here. So what we need to do is, instead of measuring the radius, we need to measure the diameter. So using the centimeter portion of the ruler, not the inches portion, the centimeter portion of the ruler, hold it to where it lines up and you find the largest distance across of the circle, which would be your diameter. Okay, so in this case here, our piston is shaped kind of like this. We do not want to measure from here to here. That is not the radius. We want to measure from here to here, and that will give us our diameter. Now, if we want to find the radius from the diameter, we're going to divide that diameter by 2. When I measured this using centimeters, it comes out to be a total of 3 centimeters. So my diameter equals 3 centimeters. Well, what is the radius? Well, it's half of the diameter. So my radius for this particular syringe is 1.5 centimeters. Make sure you guys measure the diameter of your syringe before you start, because a lot of times students will forget, and you need that information later to calculate the pressure that's going to be put on the syringe, okay, because pressure is force divided by area, and without your radius you won't be able to calculate your area. So again, make sure you record that there. Now underneath that it says, now using the formula, area equals pi r squared. You're going to plug that value in to that formula and that will give you the area of your piston. And again, if you forget to do that, you're going to be in trouble because you need that information in order to do the calculations on your data table. Okay. Now, we've got that taken care of. We put our syringe back together. Be sure that it lines up with the 60 centimeter or cc, which means cubic centimeters, the 60 milliliter or 60 cc mark. And how do you do that? You just line the edge of the black part of the piston so that it lines up perfectly with the 60 centimeters. Okay? And that's going to be our initial volume. So initially, with no weight on here, we have a volume of 60 milliliters or 60 cubic centimeters. Okay, we set this together, make sure it's on there good. So it's best to have the strongest person hold the books, and the less stronger person go ahead and read and record the numbers in our data table. Now, on the data table, on this side here, it says name of book, and book 0 won't be any book at all. Book 1 will be the first book you stack on here. Book 2 will be the second, so on and so forth. Now, you'll list these books out in the order that you're going to stack them on the piston, and then right next to it, it says force of gravity on the book in newtons. Those are the numbers that are coming off of the whiteboard. Okay, so for example, if I'm going to put my chemistry book on first, I'm going to make sure to write 24 newtons next to where it says chemistry book. If I'm placing the Algebra 2 book on second, I will write that for book number 2, and then I'm going to list out, because coincidentally it was 24 newtons also, I'll list that out where it says force of gravity from book on part 2. And you'll continue that with all 10 books that you guys have. Now the next column over shows you book 1, and then book 1 plus book 2, book 1 plus book 2 plus book 3. That's going to be the total force pushing down on the syringe here. So right now we're going to do just the one book, which is the chemistry book. And my lab partner will read this and find where the volume is dropped to and record that to where it says your data here, and then it tells you the volume of the syringe. So volume of the syringe, so I'm putting book number 1 on, keeping it balanced. It will go down a little bit, but it should stop. Now at this point, I am at 46, we'll say, and so I would write 46 milliliters down for the first book. Now, leaving this book on here, we're going to take our next book, which was the Algebra 2 book, and we're going to set it on here also. So be sure not to wiggle this too much so we don't break the seal. And again, the person who's supposed to be recording the numbers needs to concentrate on that, while the person who's holding the books needs to concentrate on that. So at this point in time, my volume is down to 31, 2, 3, 4, 5. So my lab partner would record 35 milliliters on the data table. Now, I would continue to do this, stacking more and more books up, and my lab partner will go ahead and continue to record the volume as it goes down, down, and down. Again, it should never, ever approach 0. For example, if me, a 235-pound guy, putting his weight on here, cannot get it to go down to 0, you know, 12 books should, because I'm sure I weigh more than 12 books. Okay, whoop, and see there, that's an example of breaking the seal. If that were to happen during an experiment, I would then have to pull this apart, reset it back to the 60, and again make sure everything is clamped up tight, and then me and my lab partner would just kind of roll our eyes at each other and have to do it again. So that's why you have to be careful. Okay. Other than that, you're just going to go ahead and record these volumes as these volumes go down. So you'll have to record your volumes in this column, and the volumes should go smaller, smaller, smaller. You're not going to put a book on the syringe and all of a sudden magically the syringe gets bigger. So if you see any of your numbers get smaller, 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 bigger, somebody made a mistake. This is our individual book column. Okay, so example, chemistry was 34 newtons, that would be where book 1 is. Book 2 was algebra 2, that was also 34 newtons, so that would be 34 there. Now over here where it says total force of books pushing down on the syringe, book 1 is only going to have 34 because that's all that the chemistry book weighed. Where it says book 1 plus book 2, that's going to be 68 because that's the book 1, which was the 34 newtons from the chemistry, book 2, which was the algebra 2, so 34 plus 34 is 68. So that would be the total force of gravity pushing down on the syringe. When we get to this next step, it would be whatever book 1 plus book 2 plus book 3 is, and that would go there. So again, this is the newtons and the total force that it's pushing down on the syringe. Now we go over one more step, and we have calculated pressure on the syringe. Force divided by area. Now remember, newtons is a measure of force, and the area we've already calculated on page 1 when you guys measured out your radius. So right here should be your area of your piston. So you're going to take whatever that number is on the front, and you're going to divide whatever this newtons is, the force, by that area, and you'll record those values here, and that's going to be your calculated pressure. Now the volume you guys should have already done after you've gone through and you've placed all the books on the cylinder and you've recorded that data as you go. Now in the end, these columns here are going to be used to graph your data on this graph. Now the x-axis is the pressure, okay? And so if you look over here, this is the pressure, calculated pressure on the syringe. So this is going to be your x-axis. We look at our graph, volume is the y-axis, and so if we look over here, there's your volume, that's your y-axis. So this may look familiar to you like something you've done in math class where they draw a graph or a plot, and you have an x-y plot, and you have to plot those points on a graph. And this is your graph already made for you. You just need to go over and go up, make a dot, go over, go up, make a dot, and you guys should see a pattern. After that, you're pretty much done with all your data collecting for the lab, and you just have to answer the questions, and that's all there is to the lab. Okay.
Okay, ready? 3, 2.
So, who's ready to do an experiment?